Okay, welcome back. And so now let's do some application problems. So let me read the application problem and then we'll jump in and solve it. So this is a manufacturing problem. It says the capacity C of a conveyor belt in metric tons per hour is given by the formula C equals 3.6 times S times D times A. Okay, so let me write that down. Okay, so this is the formula. Okay, notice that 3.6 is the coefficient, and then we've got three variables that are multiplied. Okay, so this is the formula. So now, S is the belt speed in meters per second. D is the density of the load material in kilograms per cubic meter. And A is the cross-sectional area of the load in square meters. Okay, so we're talking about a conveyor belt, right? So we've got a conveyor belt. Right? And so things are on the conveyor belt. Let's say you're working at Amazon and you're working on a conveyor belt, you're a sorter, right? So you're in a distribution center. And so what in the distribution center, it comes off the truck and you've got to sort it by zip code, right? So you've got boxes that come down the conveyor belt, right? And they're all stacked on top of each other. And you're on one side of the conveyor belt and you've got other people and you've got all these aisles, right? And you've got to look for your number based on zip code or letter, right? And then you've got to sort it. So the question is what's the load capacity for the conveyor belt in metric tons per hour? Okay, so this would be the formula that we would use, where this is the speed of the belt, the density of the load, and this is the cross-sectional area of the load. Okay, on the conveyor belt. So again, it depends on how much room on the conveyor belt is. Okay, so now, what do they want us to do? Okay, suppose that a certain load material has a density of 750 kilograms per cubic meter. So we have the density equals 750 kilograms per cubic meter. Okay, that's the density of the load. And the cross-sectional area of this load is 0.083 square meters. 0.083 square meters. Okay. What belt speed is needed to move 1,000 metric tons per hour? What belt speed is needed to move 1,000 metric tons per hour? Well, what's the 1,000 metric tons per hour? That's your capacity. That's your belt capacity or load capacity. So that's going to be 1,000 is it kilograms? Yeah. Oh, metric tons, I'm sorry. 1,000 metric tons. So that's going to be T. So 1,000 metric tons per hour. So we need the belt speed. We need to find S. So guess what? We're going to plug in the values. So let's plug in the values that we know, and then solve for the variable we don't know, which is speed. So let's do that. So C is 1,000, so we're going to put in 1,000 equals 3.6 and again, I can move this around because it's commutative property, it's multiplication, so I can move things around. So I'm going to put in D. D is 750 and then A is 0.083, okay? And I want the belt speed, which is in meters per what? Meters per second, okay? Now, and of course S, right? So now guess what? I'm going to solve for S. Well, guess what? If I want to get rid of these, right? So I'm going to do this a couple of different ways. So if I want to get rid of all these, this is all multiplication, right? So if I want to get rid of 3.6, because this is, again, these are factors, so this is just multiplication. So if I want to get rid of the 3.6 and get rid of the 750 and the 0.083 here, and isolate S by itself, then guess what? I'm going to have to do the opposite of what's going on here. So since they're multiplying, I'm going to divide. And I'm going to divide by each one of these. So I'm going to divide by 3.6, and I'm going to divide by 750, and I'm going to divide by 0.83. And then, of course, if I divide over here by those three, I have to divide over here by the same three. 3.6, 750, and 0.083. Okay? Now, of course, this divided by this is 1, this divided by this is 1, this divided by this is 1, and I get S. And so guess what? I get S equals 1,000 over 3.6, 750, 0.083. And I can plug this into my calculator and come up with an approximate answer. By the way, let's check our units, because again, we should get meters per second. Let's see if we do that. Well, what is this here? This is metric tons per hour. Okay? Okay, well, so metric tons per hour. And let's see, so we've got square meters, kilograms per cubic meter, so if we multiply these, let's just multiply these two right here. So D is kilograms over meters cubed, okay? Area, right, which I'm multiplying by, so area is what? Meters squared over 1. And, well, the 3.6, that's just a number. So here, what am I going to get? I'm going to get kilograms per, per meter. So, okay, so there's that, so that's the bottom. So the bottom will give me kilograms per meter. Now, what is C? Let me just make sure that I'm understanding C. So 1,000 metric tons per hour. So let me see something here. I just want to make sure that I'm understanding this right. Yeah, metric tons per hour. Okay, let me do my calculator here. And let me see what I get when I do the... Oops, come on. Okay, so I'm going to do 1,000 divided by 3.6 divided by 750 divided by 0.083, and I get 4.462. 4.462. Okay, so this is going to be 4.462. Oh, here. So this is going to be approximately 4.462. And this is going to be now they're saying it's meters per second. But maybe I'm missing something with the units. I do get meters on top. The kilograms, if I'm talking about metric tons, those are in, but those are measured in thousands of kilograms. So a metric ton is 1,000 kilograms. Oh, but that might be the 3.6. I bet you that's the units the 3.6 comes in. Okay, so I'm going to assume that this is correct. So this is meters per second. And I think that there's units on the 3.6 that I'm not familiar with. In fact, I think I know what it is. Hold on. Because the conversion from hours, hold on, what do I get? So it's going to be 1,000 divided by it's going to be oh, I have to know this. So we're down to the second. Oh, 30. Oh, yeah. That's what it is. So yeah, they're doing the 3.6 is the conversion, 2 meters per second. That's what it is. Oh, okay, because the units. The 3.6 is the conversion factor, because if a ton is equal to 1,000 kilograms, okay, and there are 360 seconds, or excuse me, 3,600 seconds in an hour, okay. So the 3.6 comes in because you're taking 3,600 seconds, right, divided by 1,000 kilograms. And so that's where the units match, because again, that's where you get the meters per second. Because here the kilograms are going to cancel with the kilograms, and then you're going to end up with meters per second here. Yeah. All right, cool. That's it. Have a great day.